Hello, in the last lesson we talked about generic types and how important they are in modern programming. Today we will continue this lesson with some specific use cases. And to know what I'm talking about, let's try to write a generic method just like we did in the last lesson. So, I have a method that returns a generic type t, and for that I try to instantiate it using the new operator and then return the newly created instance. However, as you can see, I already have an error which says cannot create an instance of the variable type t because it does not have a new constraint. Why is that? Because theoretically I should be able to use a class for the generic parameter and it should work, right? So if I were to declare a class and use it to call this method, the compiler should be able to use this class to instantiate it and return it. So why doesn't it work? The reason is, as it is right now, this method could be called with a class like we do with some class, but it could also be called with an int or a double or a type that doesn't support instantiation. Not only that, but consider this other example. In this case, we are calling getAnewT with a class, so the compiler should be able to instantiate it just fine. But if you look at this class, it doesn't have a parameterless constructor. It asks for an int I and a char c. So in this case, the compiler does not and cannot know what these parameters are and what values it should give to them when it tries to instantiate it. This problem can be solved by using a special generic constraint. One immediate effect you will notice is that the error inside getAnewT method disappears. That's because now the method mandates that the generic type only accepts types that have a parameterless constructor, which the compiler can then call. The second thing that you can observe is that the error now moved inside the main method where we call getAnewT with some other class. That's because, as I just explained, this constraint now mandates that the type that we can use to call this method must be a type that has a parameterless constructor. Some other class does not. So if you have imagined or hoped somehow that we can specify parameters that do require parameters like this, you are in no luck, because Microsoft decided not to go to this extent, so you will get a compiler error, unfortunately. There are many other generic type constraints that you can use, and you will find a link to the entire list in the description below, but for the purpose of this beginner's video, we will focus only on the most popular ones. So new means that we can use any class that has a default parameterless constructor, but we can also use this, which allows us to use any class even if it doesn't have a default parameterless constructor. But it also has more implications. In actuality, we can use this with any non-nullable reference type, like classes, interfaces, delegates, and arrays. And we have learned about a few of these, but don't stress about it for now. We will learn about them in the future. But do notice that I used non-nullable reference types. And if you remember from the lesson about nullability, that is a topic that we focus a lot on in recent years. So we do have a way to specify nullable types separate by placing the omnipresent question mark in C#. One other constraint is struct. We haven't learned about structures yet. In fact, it is the topic of the next lesson. But in short, all primitive data types in C# with the exception of string, so int, bool, char, double, all of them, they are based on structs, and structs share some similarities with classes, as we will see. But anyway, we do have a way to constrain only classes or only for structs. The only difference is that for these, we don't have the nullable variation. Then we can constrain for a single specific data type. But again, this is based on stuff that we haven't learned yet, inheritance. But what this means is that only some class can be used as the generic type for this method, or any other class that inherits from some class, and this also has the nullable variant. You can also use interfaces for the constraint, yet we haven't learned about interfaces either. The main idea is any class that implements that interface can be used as the generic type. Next, we have a combination, where the generic type t must be or derive from the type used for the generic type u. And in nullable context, if u is a non-nullable reference type, t must be a non-nullable reference type. If u is a nullable reference, then t can be a non-nullable or a nullable reference type. Next, we have the notnull constraint. The generic type must be a non-nullable type. So the argument can be a non-nullable reference type or a non-nullable value type. Anyway, as you can see, generic type constraints can be quite useful. That was all for today. Don't forget to like and subscribe if you learned something from this video. I hope you have a great day, and I'll see you in the next tech frame.